So today we will start discussing new kinds of waves, which are very, very interesting because there are many visual experiments you can perform, and it can explain many visual phenomena. So we're going to talk about light. And we'll first talk about visible light and generally electromagnetic waves, and we'll study the way optical systems work, and then we'll talk about wave properties of light, which will bring us straight into quantum mechanics. So light is electromagnetic wave, which does not require any medium for its propagation. It can actually go through vacuum. In the demo that we had last week, we saw that sound disappeared if we removed all the air from the jar. But light continued to go through. In fact, light in vacuum travels faster than it does in air or in water. So how does this wave work? This is a transverse wave, which can be made to look like this. So if I consider, so it's a wave of interchanging electric and magnetic fields. Okay, so the time-dependent changing magnetic field gives rise to time-dependent or changing electric field. And the time-dependent electric field generates magnetic field. So it's like a snake that bites its own tail. So the magnetic field along the path of the wave looks like a sine wave. And it keeps going. And at the same time, the electric field looks like a sine wave in this direction. In a horizontal direction. And the whole thing keeps moving forward. So here is probably a better picture of it than the one I just made on the board. You can see that magnetic field generates electric field, and electric field generates magnetic field, and the whole thing moves forward. And this is what light is. The same physics is involved in making other electromagnetic waves. And it's only in certain range of frequencies that we perceive electromagnetic waves as light. In other frequencies, these waves correspond to radio waves or X-rays. This is a range of frequencies of electromagnetic waves. And the frequency is shown in hertz. And for frequencies around 1,000,000 hertz, which is million cycles per second, right? This is radio waves. Then for billion hertz, radio waves become microwaves. These are the waves in the microwave oven, and the same frequency ranges, and it's also the range where the cell phones operate. Then if we crank the frequency even further to trillion cycles per second, then we enter this domain of infrared light. It is just like light, only it has wavelengths a bit longer, frequencies a bit too short, too small for us to see. It's bounding the spectrum of visible light on the red side. And then this little gap here in between is visible light. That's where all the frequencies, all the colors that we can see with our eyes lie in this little band here. If we go to even higher frequencies, we get into ultraviolet light, which we cannot see. We then reach X-rays and eventually gamma rays. That's right. And so all of these different phenomena have to do with the same type of electromagnetic wave. It's a wave in which magnetic field generates electric field, and the electric field generates magnetic field, and it moves as a wave in vacuum or in medium. So what is the speed of this wave? The speed of this wave is enormous.